Hello, and thanks you all for being here. I'm Kalvin. I've been doing C# development since it came out in 2002. How many of you remember that first version of .NET that came out? It was crazy. It was like version 2002, I think it was, and it was only available for a couple of months before there was so many problems with it that they had to upgrade it in 2003. And it's been a long time that I've been doing .NET. At the time I was doing VB.NET, and then I switched over to C#, and I've been doing that for the last probably 20 years or so in C#. I really like programming. I love the process of interacting with people, and I'm a big believer that as a group we're stronger together, and I'm a fan of collaborative programming. I think that the ideas that multiple people bring to the table helps us to create better solutions. With that being said, during the presentation tonight, I don't want you to hold questions until the end, but if you have questions, if you have comments or thoughts as we go, bring those up when we're in the particular area that we're talking about that. You may have other ideas, better ideas, something I didn't think about in the presentation. And then if it gets to be that it's going to take too long and we're not going to get through the slides, then I'll just cut off the questions and we'll have to move forward if you get too excited about what we're doing. Because I know that if you're here, it's because you're passionate about development and you want to create great solutions. That's why you spend your evening coming to things like this, so that you can be better than what you were. And all of you, I'm sure, are great. So what we're going to cover tonight is we're covering migration of .NET, C# specifically, and we're going to focus on Web API, migrating that from framework or anything before .NET 8 to .NET 8. So we are going to look at like some of the ways to get ready before you even start the migration, because the work that you put in ahead of time will pay off in incredible amounts during the migration, because you may find out that you don't need to or don't want to migrate this application. If you just jump in and start migrating it and think, oh, this is going to be easy, we just change the target framework from 4.5 to .NET 8.0, then we'll be good to go. It's not quite that easy. So getting your feet under you at the beginning will be important. So we're going to look at that preparation time. Then we're going to do a migration using the Upgrade Assistant of a small project. And then after that, we're going to look at some code samples of changes that have happened over all these years that you will find in .NET 8. These are all things that at one point or another during our migrations that they kind of tripped us up, and we had to go and figure out what was going on and how to make this work in .NET 8. And then we'll have any questions that you didn't ask along the way. What you need to know before you even start the migration is you need to find out that you are ready, emotionally ready, technologically ready, time ready to learn a lot. Because when we started doing migrations, I work for Farm Credit, and we started doing migrations. I started with them a little over a year ago, about 14 months ago. And I went into it with the belief that migrating code from framework to .NET 8 or .NET 6 would be relatively easy. There's an Upgrade Assistant, you run that, it does a lot of the work for you. You have to tweak a few things and you're off to the races and ready to go. But any of you that work in enterprise applications know that an enterprise application gets real complicated real fast. And so we do a little bit of migration, we do a lot of learning. We do a lot of collaborating. Hey, have you seen this before? Do you know why they removed this? What replaced this? And sometimes the answer to what replaced this functionality is nothing replaced it. They removed it on purpose because of issues that that functionality caused in applications and security and reliability. So it's be ready to learn. The next thing is understand your application. And this is something that I didn't take seriously enough at the beginning of our migration efforts. And we would look at the application, kind of browse through, see how many controllers there are, see how many classes there are. Oh yeah, this doesn't look too bad. But but I didn't really understand who's using the application, how are they using the application, what parts of it are still in use, because there could be controllers that nobody ever calls, or there could be in a controller, there could be 10 endpoints. One of them gets used, 9 of them never get used. And the really complicated functionality is in one of those 9. Can we just remove those from the application because nobody uses them? How does this application work? What kind of dependencies are there from this application to external services, either within your company or external services that you paid for, like third-party services that you pay for getting information? Do they have libraries already for connecting and for using their service that are ready for Net 8? I have to be really careful in my terminology, because for a long time it was Net Core, Net Core 3, Net Core 5, but Microsoft has really gone away from the idea of Net Core anything. Now it's Net 6, Net 7, Net 8, and it's just understood that when we talk about Net 6, that is .NET Core. Now, part of the thing that makes it a little bit confusing is that in some Microsoft documentation, you'll still see the term Net Core something, Net Core 6, because it's just all over in their documentation. But keep in mind that Net Core and Net 6 are exactly the same thing. They're the same framework. So if I say Net Core 6 or Net Core 8, just realize that I mean Net 6 or Net 8. So understanding your application, what uses it, what you use, right? What are the landmines, the pitfalls, what I call the dead bodies that are in the application, the things that are going to really trip you up, that are going to be a challenge. Understand those things. And the testing will help you find those things, those problems in the application. Does your application have adequate testing? Before you start the migration, it's good to look at your testing strategy, your testing plan. Is the application covered? Are the hard parts at least covered? Do you have unit tests? Do you have integration tests? Do you have smoke tests? What about performance testing? How do you know when you get done with the migration that you haven't killed your performance in your application? How many requests do you get in a certain amount of time? How many requests per minute, per hour, per second? Whatever type of application it is, how many can your application handle? Can it handle 5 per minute? Or can it handle 10,000 per minute? It's good to know those things going in so that you'll be able to test that again after the migration and see, is everything the way that it was or better? Because .NET 6, .NET Core, any of the versions of .NET Core, the whole plan was to make it where it was easier to develop, better performant, and easier to make changes in it. So, if it didn't do that, then either something happened in the migration, or maybe a module, a piece needs to be rewritten in a different way that can take advantage of .NET Core better. And the last thing, know what environment do you want to move to. All of you know, I'm sure, that .NET over the years has been for developing Windows applications. You can develop applications to run on IIS, you can develop WinForms, you can develop console applications, but they were going to run on Windows, or at least something that looked like Windows. Do you still want to run this application on Windows? Do you still want to run it on IIS? If you're like me, you don't, because I hate running applications on IIS. It's just so complicated. What I want to do is I want to run my application in Docker, because Docker simplifies my environment, because I have flexibility. I don't have a huge bloated server environment for running a couple of small applications. Depending on the size of your enterprise, maybe you don't need a whole server dedicated to it. Maybe you can move parts of this into Docker, and that's everything that you need. So know where you want to target your environment. Where do you want to be able to run your application? Do you want to be able to run it on-prem? Do you want to have the flexibility to run it in AWS or Azure or somewhere else? So understanding and knowing that will help you to know what you need to do for your application. Now, if you choose to not have testing in place, you choose not to understand your application, then you could wind up in the CFO's office trying to talk them into a plan like this. Our goal is to write bug-free software, so I'll pay a $10 bonus for every bug you find and fix. Now, if you don't understand your application, chances are during the migration you're going to create a lot of bugs. And they may be difficult to hunt down and find and fix. So, in the second pane, they are all very excited. Yes, 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 we're rich. And I hope this drives the right behavior from the pointy-haired boss. And Wally says, I'm going to write me a new minivan this afternoon. Don't write a new minivan. Take a breath. Pause at the beginning of the migration and make sure that you go into the migration prepared. Mentally, technologically, that you understand that you have your testing in place.
Quick question.
Yep.
On the bugs, there's kind of usually two strategies. What you really think is a better? So one is you see the bugs when you discover a bug when you're migrating. One strategy is to fix them. The other is the bug is here, should be a bug is here. So what's usually you think is a better strategy for such cases?
It really depends on your appetite for technical debt. How important is this piece of the application? My preference is that if I find a bug, I want to fix that bug. I don't want to wind up that at the end of the migration, now I have 50 bugs that I've introduced that I need to fix. However, if it's a small application, you have two controllers, you could go ahead and migrate them both, even though you have some bugs. And we're going to see that at the end of running the Upgrade Assistant to migrate your code, that it will be an unbuildable application. So you're going to start out by needing to go through and fix all of the things that the Upgrade Assistant couldn't fix for you. But if you do find bugs, it's my preference is to fix them as I go. Yeah. Anybody else? What is y'all's preference?
Sometimes, so the reason why I bring this up, so sometimes this could be a bug-like behavior, or clients might be having workaround, and potentially with migrating you can break them. So discovering that is quite challenging.
For sure. Yeah, and if you have an adequate testing plan, then hopefully you'll find the bugs before it ever gets to the client. If you have code coverage in your unit tests, then you'll find lots of your issues that were created during the migration. If you have postman tests that are set up to be able to fully test your API endpoints, then you'll find any big issues that are going to cause runtime errors. However, you can still wind up with that you didn't necessarily create a runtime error, but it created a difference in what the customer was expecting to get. And this can happen as part of the migration. It can also happen as just because there's new technologies that you're introducing here. One of the challenges that we ran into recently that I thought was really quite exciting to find this, because I didn't know that this was something in the landscape of running web APIs. And that is that we made heavy use of the reason phrase for communicating back to the caller to know why they got the error that they got. If they got a 404, we would put something in the reason phrase to say why they got the 404. Well, they had written applications that were expecting the body to come back empty, and they would look at the reason phrase to know why this 404 is there so they know what to do to fix it. Well, the RFC for HTTP2 took out reason phrase because they want to reduce the amount of data that has to go across the wire, and the reason phrase is really there for human readability to make it nicer for people. And their idea was that if this is an API being consumed primarily by an application, both ends need to communicate about what the expectation is. So what they put in place of it is an object called a problem details. And a problem details is an object that will contain information about the error, and you can customize it, you can add additional information to it, and then you return that in your response instead of returning something in the reason phrase. However, if your clients are looking at the response and expecting it to be empty on a 404, and maybe they didn't program around the idea that maybe there's something there, but it's not what they expected, then they're going to have errors in their application. So, I thought that was really neat to discover that. It's not really necessarily a .NET thing, but it is the kind of thing that you'll run into in migrating to .NET Core, migrating to Docker. Maybe if you're moving this to Docker to be able to run it in Azure or AWS or some other system, then there's other technologies that wind up being introduced that you also have to be able to account for. And that's why it's important to have a solid testing plan, because you need to be able to test all those things and make sure that you have parity between your pre-migration code and your post-migration code, that they're the same, or any differences can be communicated to the users of your API. Does that make sense? Okay. So, in your migration, you want to choose your target framework. The TFM is the target framework moniker, and it's just a little thing that you put into your CS_proj file to say, what is my target framework that I want this application to be? It could be a particular component. They don't all have to be on the same version of .NET. You could have some in Net 8. You could have other components that are in Net 6. Maybe you have some that are in Net 8, some Net 6, and you still have something that's running in an older like .NET framework application, because there's functionality in there that you can't upgrade. And so you may keep those on Net 4.8.1 or Net 4.5. It just depends. But know what is your target framework that you're wanting to go towards. Besides the target frameworks, there's also the ability to have it a target framework, and you can put in there a piece that makes it available for a specific operating system. So if you have it targeting Net 8.0, it's expected that it's completely .NET Core. It can run on Windows, it can run on Linux, it can run on Mac. However, maybe you have functionality in there that requires this application to run on Windows. You need it to be able to access Windows resources. Then you would give it Net 8.0-Windows. And now you'll be able to access Windows features, and you can use everything that's in .NET Core, but you won't be able to deploy this to Docker or Docker or Mac, Linux or Mac. When I think of Docker, I just think of Linux, even though I know that there's Docker containers that run things besides Linux. But so if you put Windows-specific functionality, you either have to give it away that you can translate from the Linux or the Mac system into the Windows system to be able to access that functionality. There's also other OS-specific TFMs that they support. You can give it Net 8.0-iOS or Net 8.0-Android. There's probably 8 or 10 of them that you can target specific operating systems that you want this particular application to target. Because we're primarily talking today about Web API, but really .NET Core, you can create almost any application that you used to be able to. There are some that you can't. They're trying to get away from it. One of the things that you can't really do in .NET Core that I'm aware of anyway is WCF, the Windows Communication Foundation. It is not available in .NET Core because Microsoft is working on getting rid of that. So it's not available. And then UI applications. You can still create UI applications in .NET Core, in any of the versions of .NET Core. You can still create UI applications. You just will likely have to use one of those TFMs that targets a specific type of application. But you may look at the application that you have and you have to make the decision, do we migrate this or do we write it new in something else? Do we migrate the API but rewrite the UI so that the UI can run in something like Maui or Blazor Pages or something like that instead of a WinForms app like you've had for a long time? Maybe this is a chance to rewrite that. Any questions so far? Okay. One of the pieces of technology that that Microsoft has written that I really like using, and I think that they've done a pretty good job, and they're continuing to work on it, is the Upgrade Planner. Have any of you ever used the Upgrade Planner? No? Okay. So the Upgrade Planner is a great tool to find out what are the dependencies of our application. This is an application that was written by Microsoft, and they're continuing to develop it. But it's considered an experimental tool, but it does work really well. When you go to download it, you do have a couple of options. You can either download an executable, and Windows Defender, if you're on Windows, Windows Defender is going to give you a lot of grief about running this application. Your security people at your company may give you grief about running this application because it's an experimental application. However, what I've seen so far is safe. If you don't want to just download an application and use it, you also have the option of downloading the source code for it. And I have the source code. It's .NET/APIs of .NET. It's on GitHub. You can download the source. You can tweak it all you want. You can make the changes that you need it to have, fix bugs, and put in pull requests. And I'm sure they'll be happy to look at your pull requests and help improve the application. And the TFM for this Upgrade Planner is Net 8.0, Windows. So you have to be on Windows to use it. Unless you go in and rewrite it and make it where it doesn't need to be on Windows. But I'm sure they would love that too. But being able to download the source code is very nice, because then you can look at it and see, how does this thing work? Let's take a look at what the Upgrade Planner does. One of the things that's important to keep in mind about the Upgrade Planner is it will give you a lot of information. It does a lot of digging into your application, but two pieces of information that I want you to understand about it is that, number one, it's not looking at your source code. It's looking at compiled binaries. If you just give it point it at an application that's all source code and it's not compiled, you don't have the binaries for it, then it's going to give you, I thought this would show up here. It doesn't. Let me stop the presentation, and then hopefully it'll show up here. Sorry about this. There we go. Okay. So it gives you lots of information about your application, but it's all based on the binaries of your application. So you have to be able to compile it. If you can't compile it, the Upgrade Planner isn't going to be able to help you very much. It'll tell you what libraries that you're using, but not necessarily how they're using them. This is an example of pointing it at a repository that I haven't built yet. And so you can see that it gives me a lot of information about the binaries that do exist, mostly from NuGet packages. Anything that's up here that's in red means that there's problems, there's errors with that to be able to use this desired target framework. If it's in yellow, there's warnings, and if it's gray, there's no problems. Now right now that is set for a desired framework of Net 9.0. However, for any one of these libraries, I can always choose that, change the set desired framework, and I can change that to Net 8.0, if I can find it. And now it'll refigure all of its warnings and errors based on targeting Net 8.0. Now, I'd said that there's two things that I want you to know about this. One is that it targets the binaries and not the source code. The second is it doesn't go out to NuGet and try to find packages that will work for this desired framework. It uses exactly what you have available in your repo, and only in that one repo. It doesn't go to your machine-wide NuGet repo that's under your user settings. It just looks in this one library. So, even though there may be some that says, hey, we don't support this particular version, they don't have a Net 8.0 version, that doesn't mean that one doesn't exist in NuGet, and you'll just have to update your application to use the correct NuGet package for the version that you need. So, in here, we have a lot of dependencies on libraries that aren't our dependencies, right? They're dependencies on third-party tools, things we downloaded from NuGet. Maybe there's applications that we bought from somebody. And so what we can do is we can go in here and we can select the things that aren't our application. And it may be most of the things that are in here. Oops. Let me do this. We can clean up our view here. We can remove the things that aren't our application. And you can see here that because I don't have a compiled application, none of this is my code. And that would be my indicator that, oh, that's right, I'm pointing it at a repo that I haven't built yet. So if I change over to an upgrade planner that is a compiled application, now we will see that I do have code in here. At least I should. I did when I was putting this together. There it is. So all of the things that aren't mine, I want to remove. There could be a reason why you may want to keep one of the others in there for being able to like see how it interacts with other pieces in the system or something like that. But in the application that I'm targeting here, there's only 3 things that I'm looking at, which is my code, right? I may have to go in and update my NuGet packages. There may be some functionality that I just don't have available anymore, like remoting. Remoting is not available on .NET Core. So I know before I ever start the migration process that I'm going to have to find a solution for remoting. Sir?
So is this doing dependency walking, essentially?
It's looking at what dependencies that you are using, and then it inspects those dependencies for functionality that's not available on .NET Core. So I don't think that it's going from one assembly and doing like a decompile of it and looking to see what all it's using. But I haven't really looked at the code to see how it goes about doing its work. It just shows you how your dependencies, kind of your dependency tree.
That's what I mean, like the view down below with the green, the red,
Yep.
gray, and blue.
Uh-huh.
That's your dependency structure, right?
Yes, Yep. This eShop Legacy MVC depends on eShop Legacy Common, and then there's an eShop Legacy.utilities, and neither one of these are directly dependent on the utilities class.
So then does it also show you which framework, DLLs or binaries, those could be dependent on?
They do, except for I just removed them. Yep. And so without that, it would show me that whole big tree that we started out with is those dependencies that these are set up and that they're using currently. Yep. Now, right now I have this targeting net 9.0. I can go in here and see maybe a net 8.0 or maybe net 6.0. Maybe there was some of this functionality that was still available. And so I can change this to net 6.0. And I can see, did it change anything? No, remoting is still not available. Because Microsoft is continuing to make changes to their .NET Core environment. They're still working on deprecating some things that their security has decided that this is just not a good idea. So it may have been available in .NET Core 5, but not available in 6 and forward. It may have been marked obsolete in 6, and then by 8, they take it out completely because they really want to encourage you to stop using it. And so they first make it obsolete so that you can find that there's a problem here. You can have it now a couple of years to update your code before they actually remove it in net 8. Another piece that is deprecated is system.web. It's just not available in the .NET Core environment anymore. So there's lots of resources out there for what do I replace this with. And for some of the libraries that they don't support anymore, it may be that that library now, that same functionality is broken up now into multiple other libraries. Maybe you only need one small piece of this. Instead of having to bring in this whole big library, you can bring in one small library that gives you just that one little piece that you need. And that's part of my belief, part of what they do to make it run faster, build faster, it's more efficient, does its work better. So, but going through this and understanding especially the things that are red, understanding what their problems are, how much work is it going to be to fix this, have I seen this before, how critical is this functionality. If you have got to have remoting in your application for it to do anything that you need it to do, then you just won't be able to upgrade that application to .NET Core, because Core doesn't support the functionality that you need. Maybe your upgrade path, if you're on currently Net 3.5 or currently on Net 4.5, maybe you upgrade to Net 4.8.1, which is the highest framework version pre-Core that they have. And the intention is that Net 4.8.1 is going to stay around for a long time. It's kind of their long-term support for people that have functionality that are critical for their applications that keep them from being able to upgrade to .NET Core. So upgrade it to Net 4.8.1. It's a much easier path. And I've seen lots of people that talk about that even if they are upgrading to .NET 6 or 7 or 8, that they first upgrade to Net 4.8.1 so that they can kind of get a lot of the kind of older functionality. They can find a lot of those pieces and clean them up in their system before making the final jump to .NET Core. So they kind of take a two-step process, and they upgrade first to 4.8.1, then they make sure that that's stable, all their tests are running, their performance is good, and then they decide, okay, now from here to Core, what is what's our path to be able to achieve that? Or do we just stay on Net 4.8.1 and call it good? Any questions?
I think you've answered this indirectly, but since you mentioned it needs to be able to compile to run this, is there a general strategy or ideas, because this might just be a it depends answer, where let's say like a lot of EF Core stuff has changed from my understanding over the years, so it doesn't even compile. Do you have an idea or strategy or tool, or is it just kind of case by case? Because you have to compile obviously to use this.
Right. Yep. So you won't be compiling it in .NET Core to use the planner unless you're upgrading from like Core 1.0 to Core 8. And so if you're in like an older framework, 4.6 or 4.5, then and it doesn't compile, to be able to use this planner, you have to find out what's keeping it from compiling. The things that were available should still be available to that framework. However, I have found that it is very difficult to find useful information on some of the older frameworks. Like if you're on anything below about 4.6, it is very difficult because it seems like Microsoft has made an effort to kind of clean that stuff up. And that way you don't go and do a search for using some piece of functionality and now you're getting things from the last 20 years of Microsoft documentation about this and all these different framework versions, and you're having to dig through that. So, but it is there. You just have to find it. Almost everything that I search for seems like it always comes up with Core 1.0 and up. So even being able to go and download some of the old targeting packs, you can still find them and download them. If you need the 4.6 targeting pack, you can go out and find it, download it. But I don't think that like the Visual Studio installer, I don't think it even has access to it. But it might. I would look there first for the targeting pack and for the SDKs.
I think anything that's not supported as a targeting pack currently has to be downloaded manually and installed. That's been my experience. So.
I have had where I was opening an older application. It was like, I think it was 4.6 or something. And so when I opened it in Visual Studio 22, it said, hey, this is an old thing. You don't have it on your machine. Do you want me to upgrade this to 4.8.1? Yes. And it upgraded it to 4.8.1 and I didn't have any problems. However, you could, depending on what's in your application, how complicated it is, you could upgrade it and have issues. And that reminds me, I meant to point this out on an earlier slide, but I forgot about it. One of the critical things to have set up before you start the migration is by all means have this in version control. I know that there are some people that dislike version control for some reason, and there was a group of us talking the other day, and there's still lots of people that don't trust version control systems, and they all have their story about that they made all these changes and somebody came and chomped over them, and they lost these changes that took them 2 weeks to implement. Have a version control system, and then just know how to use that version control system so you don't accidentally lose your changes. But when you do your upgrade, you may get the upgrade done. You do that in a separate branch, and if you have to, you can always revert back to main and make any like hot fixes or things that need to get out to the customer, or this migration. You thought it was going to be a 3-day migration, turns out it's going to be a 3-month migration. You still have your main branch that you can continue to work off of. So having it in version control is incredibly important.
Hey, Kalvin.
Sure.
Before you move on, can you talk about platform compatibility and how this works?
The desired platform. So, right now the desired platform is any. But maybe I want my desired platform. I know that I'm not going to run this on Windows. I know that I'm not going to run this on iOS or Android or anything else. Maybe I know that I want to run this on Linux. So, just like I can set my desired framework, I can also set my desired platform to either one or more desired platforms. So if I choose Linux, then it'll give me my errors for Net 6.0 and Linux. And I can change this and say, okay, I don't see anything too bad there. Let me change my desired framework to Net 8.0 and see if it really changes anything. Maybe you're more familiar with 6, so you start out with 6. So I change it to 8, Linux, and my list seems to have gotten a little bit smaller. But there's still some things in here that are not available and are never going to be available in .NET Core, and that's remoting. Any other questions on this before we move away? Didn't start at the slide I wanted. Okay, so we're about to start running the Upgrade Assistant, and it's common to wonder, I have multiple projects. Maybe you have a solution that has 20 projects in it. Each project has a piece of your application. You're an interior application because you're all good software developers and good architects, and you want to create systems that you can maintain and manage. So you have 20 projects in there. Where do you begin? Where you begin is at the lowest level. You start with the application that doesn't have dependencies on anything else in the application. And then you can use the upgrade planner to see that dependency tree, and you can use that to plan the order that you're going to migrate your projects. That utilities project, it didn't depend on anything, nothing depended on it. That's the logical place to start. And then you start at the bottom and you work your way up. And by the time you get to the last application, which is probably going to be your main API application, where your controllers are, by the time you get there, everything else has already been migrated to Net 8.0. And then when you migrate it, it's going to look at those projects that have already been migrated. Now we have two options for running the Upgrade Assistant. I hope that the color of the text doesn't make it difficult to read, but I suspect that it does make it difficult to read, so I'll apologize for that. You can do a global install of the Upgrade Assistant, and it's just a .NET tool install -G Upgrade Assistant. And that will install it so that you can run it on the command line, which can be very handy for writing PowerShell scripts that can inspect a directory. You can look at the dependencies like in your script, and it can make the decision on the order that it's going to upgrade your projects, just depending on how much time you want to put into developing that. If you have lots of applications to develop, then the time you spend writing that tool to do this analysis and to spit out the command line to do the Upgrade Assistant, you can start that, go to lunch, get some coffee, and when you come back, it's all done. And of course you'll have no errors and everything is going to be great, and you go home for the day. Not so much. The other option is that Visual Studio now has an extension that you can install in Visual Studio that allows you to just right-click the project and choose Upgrade, and it has a little wizard that takes you through upgrading that project with the options that you have. Now, the Upgrade Assistant used to bring with it some additional functionality besides just upgrading your application. It used to have, you could do an upgrade, you could also do an analyze, and that analyze would look at the source code for any kind of problems like what was in the upgrade planner. However, I think Microsoft is trying to push us towards using the upgrade planner, and that's where they're putting their effort, is in developing that tool. And now when you run the latest version of the Upgrade Assistant, the only option you have is upgrade. And we'll take a look at that in just a moment. So their idea is that you use the upgrade planner and then you use the Upgrade Assistant for actually doing the migrations. So the basic thing about the Upgrade Assistant is that it automates the routine parts of the migration. The hard parts, you're still going to have to go in and figure out, because it's not going to be able to do everything. It works like a lot of other tools, that it has a long list of rules, and it says if it's this type of thing, then decorate this with this, and put this here, and put this here, a template, basically. And it migrates your code using that template. So if we start out by looking at the Upgrade Assistant and just what's available in it, once you have the global install, you can just run Upgrade Assistant --help, and you can see what the different options are. And there used to be that you had Upgrade Assistant and then you could do analyze, and there was a couple of other commands that you could give it. And now it's all just Upgrade Assistant, upgrade. And then you have some options for what's your target framework, because you can use the Upgrade Assistant. If you use the latest version, you can use the Upgrade Assistant to migrate all the way up to Net 8.0. If you have an older version of it, then Net 6.0 or Net 5.0 may be the top version that you can migrate to. But you can give it options for each of those pieces, which are all available in the UI for that also. Any questions so far? Am I going at a good pace? Okay. So in here, we have an extension for the Upgrade Assistant, and you just install it like any other extension. You just go to extensions, and then you find the extension for Upgrade Assistant and install it, and then it will be available for you. Now we know that we want to start our upgrade with utilities, so if we right click on that and choose Upgrade, I hope the text is big enough that you guys can see it, or I'll say what it says. That way you'll be able to find it again later. So when I choose that, it just has some text here, welcome to the Upgrade Assistant, and I can upgrade my project to a newer .NET version. It also had to upgrade some project features. But everything that I've done with this so far has been upgrading my project to a newer .NET version. Now here is where you've got to really make your first big choice, which is I can either do an in-place project upgrade or a side-by-side project upgrade. I like the side-by-side project upgrade because it leaves your original project completely unchanged, and it creates a new project, and then it migrates your code from your old project into your new project, and now you can see them both side by side. However, if it's a small project or you feel very confident, especially if you have version control, then you can always go back to your master branch or your main branch and look at it. But if we choose side-by-side project upgrade, and then I'm going to say I want this to be a new project. Maybe you've already created a project and you want to migrate this into that project. You could choose existing project. But if I choose new project and click next, then it's going to create a project named the original project name with core appended to the end of it. And we're not going to go through all of these. I just wanted to walk you through using the wizard, and then I'll show you what it looks like at the end. And then I can choose Net 6.0, 7.0, 8.0, or 9.0. I can also choose Net Standard, by the way. It has Net Standard 2.0 if that's what you need. and it says these are the things we're going to upgrade, and maybe you say, oh no, I know that this class has lots of problems, I don't want you to touch that, I'll go in and figure that one out on my own, but I just let it upgrade everything. It says, okay, we've got 15 things to upgrade, and it gives you a little counter here of where it is in the process, and gives you some nice output so that you can see what's going on. And you can look through here and see everything that was able to be successfully upgraded or not. And now we have a new project, Utilities Core, and we have our updated code in here. It's very small, so it's pretty easy to migrate. Now, after that migration is done, then we have our projects. We have Common Core, we have Utilities Core, MVC, and MVC Core. One of the things to keep in mind, though, is on some project types, you'll have to do a multi-step migration because it can't migrate the whole application at once. So what it's going to do on this MVC application, it will migrate the core application structure, but it won't migrate the controllers, it's not going to migrate the services, it just kind of migrates the core structure, and then it sets up a proxy between the old application, between the new application project and the old application project, so that they'll still run, but everything isn't in Net 8.0 yet. Then you would have to go in and do the migration assistant on that project again, and you can choose specific controllers that you want to migrate, and you can migrate the controllers one at a time. And when you migrate a controller, like here, we see that there's an account controller. When I migrate the account controller to the new project, it will migrate that and everything in the project that it depends on. But it allows you to be able to do it more piecemeal. Instead of having the whole thing done at once, you can migrate a piece of it, go and see how did it all work. You can go and fix those errors instead of getting to the end and you have 200 tickets or bugs or problems that are in it, and now you're trying to go through and fix it and it's just full of issues. You can do them one at a time, fix those issues, move on to the next controller. So it's pretty handy that way. Keep in mind that on your migration, the Upgrade Assistant isn't the only option that you have. You also have the option of just creating a brand new project. And that way, if you're creating a web API, create a new web API project. And then just go and manually move your classes over and you do the work that the Upgrade Assistant would be doing. If it's a simple enough project, that may be easy enough, but it gives you direct control over exactly what's happening. Instead of the Upgrade Assistant doing what it thinks it should, you can go in and upgrade and fix each of those pieces on your own as you copy the classes and the code over to the new project. It's kind of the same thing that they're doing, except for you're doing the heavy lifting instead of the Upgrade Assistant. Any questions? Sure.
So in a previous application, it will show that the remoting is not available as part of the dependency for one of the projects over here.
Yep.
But looks like it was able to upgrade it. Did it try to use something else, or it's a different project?
It won't build. Yep. At the end of running the Upgrade Assistant, if it's a very complicated project, if it has things that the Upgrade Planner has tagged with red, when it gets done running the Upgrade Assistant and you start opening the classes that are using some of this functionality, you'll see that it's full of red. You may still have to go and upgrade some NuGet packages to be able to get the specific functionality that you need. You may have to completely rewrite some methods or some specific lines of code to be able to get your same functionality.
So in our example, you kind of like resolve these issues before in the second.
Yeah. Ideally, you would say, okay, I know that remoting's not available. What am I going to replace that with? And so you may have to have some meetings with senior developers, architects, other people to say, how do we as a company want to replace remoting? So that whatever you do on this project, you can do across the enterprise. Maybe you're going to wind up creating some shared library that will give you the functionality that you need to be able to replace the functionality that they don't support. And that way, as other people are migrating their projects, you can document this somewhere that for remoting, use this library that we have available in our company's private NuGet source. Or we found this third-party tool that will give us the functionality that we need. Use this tool. And that way you have consistency across your applications at the end of the migration. And that helps with the consistency and for being able to knowledge share amongst the other people in the company, because they don't all have to go and figure it out. They know to go to this place to find the things that your architects or lead developers have put in place to fix these issues. And then other migrations will go much faster. Your first migration may be really slow because you have to develop all these tools, find all of these problems in like how your company's code is developed, and then you're going to figure out what are the alternatives for that. And then your next migration should go faster unless you find new things that you didn't find in the first migrations. Any other questions? Okay. So, what are we going to find in Net 8? So at the end of that, we have an application. We go and fix those issues, say that everything in our new shiny Net 8.0 application, everything is working good. What are some major challenges that we're going to find in the way that things worked before and the way that things work now? Let's see, how do I start this from my current slide? I know there's a button for it.
Over to the right a little bit.
Is it? It's not one of these. It's way over here, isn't it? Nope, nope.
I think it's to the left, just to the left of the zoom slider. I think that's the one.
That's, oh, right there. Nice. Thank you. Okay. So, what type of applications does Net 8 support? It's talked about a lot, Net 8, as being an application for like web APIs and things like that. But you can actually create most of the application types that you used to be able to create, except for like WinForms, WPF. And you can create those. You just have to mark them as Net 8.0-Windows, and then you can still create WinForms or WPF applications. But you can create a console application pretty much the same way that you used to be able to create a console application. You have your void main, take in args, and you write all your code and create classes, whatever you want to do, like you always did in a console application. However, you also can create hosted applications using the Create Application Builder or Create an Empty Builder. And you might be wondering, okay, we have host.create application builder, we have host.create empty builder. What's the difference? One of the things that Microsoft has done in Net 8, well, starting with the beginning of Net Core, and they just continue to enhance the environment, is they made it where a lot of the things that everybody has to do gets baked into the system that is available. So you're running an application, you're going to need configuration. So instead of you having to write your configuration, loading up app settings and app settings.development and app settings.production or whatever from your different app settings files, having to go and load environment variables, loading in args, getting stuff from, say, some sort of secret storage location or the project's secret settings if you're in development. Instead of having to go and code all that yourself, if you create an application builder, all of that will be baked in for you. You can pretty much create the application builder, add any special logic that you need, and call app.run, and you'll be running your application, and you have a logger, and it's a real logger. Back in, I think it was the early days of .NET Core, when you would create an application, you would have a logger so you could pass it around through dependency injection, but it was a null logger. So it didn't really do what you needed it to do because it wasn't going to throw an exception. It just doesn't go anywhere, right? But now in Net 8.0, and I don't know what version they started it, I think it was in Net 5 or 6, they have a console logger that is the default logger when you create an application, create application builder. But, so what does create empty builder do? Well, maybe you don't need all that stuff. Maybe you only need configuration settings from one app settings file or from ARGs. You know you don't have app settings, you know you don't have environment settings, and all of the other things that the Create Application Builder creates for you. You don't need that. So why bloat your system up with all of this extra code and dependencies if you don't need it? Create an empty builder, and then you can just add the individual pieces that you need. And so these are specifically for hosted applications. These aren't going to be for creating a web API. It'll be a hosted application within your application. The web application.create builder, that one does create a web API, and it has all of those same kinds of things in it. It has your configuration. It creates a web environment to run your application, and they can be in IIS, IIS Express, Kestrel, and that's all configurable as to where your application is going to run from the Create Builder. So it's going to load up configuration. It's going to create that console logger for you if you don't tell it anything different. Like you can tell it to create a different logger through configuration settings in like your app settings file or something. It automatically creates your DI container. So if your dependency injection system was Unity and you have all of this code in your startup class and configuration class for configuring Unity and running Unity, now everything is pretty much there for you as far as having the container and being able to do the dependency injection into your controllers, into your service classes, and pretty much anywhere in the system. It creates that for you. And then the web host, being able to host the application for the web. Any questions? Okay. Something to realize about the configuration, though, is there's a very specific order that it's going to load your configuration settings. And it's important to know what that order is. Because if you have the same key but different values, and you put it in app settings and app settings.development, then if you've been using those, you know that it's going to load your app settings, then it's going to load your app settings.development over top of them. So whatever you have in app settings.development, the values will overwrite the value for the same key. And the same thing happens if you have an environment variable, then it's going to, and that environment variable's key is the same as one that's in your app settings, it's going to overwrite that app settings value. So if you have variables set up in multiple places and you have the configuration settings to be able to access all of those places and you're getting values that you didn't expect, I would look at the order that it loads those configuration settings and decide which one is the one that you really want to maintain. Maybe you don't want them in environment variables. And so it's like, oh, then I need to remove those from my machine's environment variables. Any questions on that? Okay. The next piece is the things that are not supported. One of the interesting things that we ran into is we developed our application, everything seemed fine, and then like everything built, we had no problems, but then when we went to run it and we had called a controller endpoint and expected to get back whatever it was that we wanted back, instead we got back an exception of not supported exception. And it's like, what? If it's not supported, why did everything build? Everything is just fine. And it may run just fine on Windows, but then break whenever you put it into your Linux Docker container. And that's because depending on the runtime that is being used at runtime, it could be that a particular functionality is supported in one runtime, but in another runtime it's going to throw that not supported exception.
Have you run into anything concerning around reflection?
I have seen there's something about reflection that doesn't work the same as it used to, but I don't remember what it was. It was something about there's a change in reflection, but I don't remember what it is.
Or maybe loading DLLs dynamically.
Yeah, that's what's different, is dynamic loading doesn't work the way that you expect it. They do have a workaround for it, but dynamic loading in general, basically you won't be able to compile if it's not compatible. So as long as you're specifying a platform, that's the key. Specifying your target runtime and where you're going to be executing it, whether it's Linux, Windows, or whatever matters at that point. And you'll get a compile error saying it works on Windows, but it doesn't work on Linux.
So if you've already pre-compiled the DLLs and you're basically instantiating stuff out of them, is that equivalent to what you're saying, or is it?
No, so when you compile your assemblies, you're compiling it to the IL code, right? And then whenever you deploy it to your target system, then that target system is going to either have on it, or it's going to take with it the runtime libraries to be used on that target system. So you would wind up with different runtime libraries on Linux than you would on Windows. So on Windows, it may work fine, but on Linux, it's going to throw that exception because the runtime libraries are different.
So those are, aside from a platform difference in that case, you wouldn't foresee there being an issue, would you?
No, outside of being like a specific platform or runtime. Yeah. Just know that just because it compiles doesn't mean it's going to run without throwing exceptions, depending on what it is you're doing. So a couple of the things that are not supported that I found particularly interesting, like system.drawing is like, okay, this makes sense that unless you're on a Windows system or you use a Windows TFM, it makes sense that system.drawing probably wouldn't be available because it's going to be dependent on the target platform's system for drawing. But like the binary formatter is something that Microsoft has been trying to get away from for quite a while. And in Net 8.0, I don't think it's completely gone. Like your stuff I think will still compile, but when you try to use the binary formatter, it's going to throw a not supported exception because they don't want you using the binary formatter. And that doesn't have anything to do with whether it's on Windows or Linux. There are some like flags that you can put into your application that will force it to still use the binary formatter if you have like a dire need for that. But you're better off to find a workaround so you don't need the binary formatter. And that was taken out specifically for security and reliability issues. Because when you're doing the binary formatting, maybe you don't know exactly what's in there or what kind of security problems you're introducing into your system. Or if you're logging that or sending that over the wire, then you could have some security implications from that.
They were trying to take it out even in 4.0, so they've been trying to get rid of binary formatter for a very long time.
Yeah, there's quite a few things that like they're handy in a way, but they just create problems, right? And so this gives you a good opportunity to find a workaround. Another one, and I think it kind of follows in the same vein, is the serialization. So passing in serialization info into the constructor is something else that Microsoft is working to get rid of. And in Net 8.0, I'm not sure if it's a not supported exception. I think it's a not supported exception versus that it won't build at all. But just realize if you're wanting to pass serialization info into a constructor in Net 8.0, you're likely going to have problems with that. There are some really useful pages that is available on Microsoft for being able to find like unsupported libraries, unsupported APIs, and if you go to that page for unsupported APIs in Net 8.0 or Net 6.0 or whichever your target framework is, then you can scroll through that and it's a very long list of things that are either not supported or not supported depending on the platform that you're on. I encourage you to go look at that long list. These are just a couple of them that I found interesting. One that I don't know how many people use it, but it's the app domain to create a domain. How that works, they still have something similar available. It's just not going to be like an app domain like that. So it's different. Something that I really like in new .NET Core, I know that it's in Net 6 and on, but I'm not sure at what point they introduced middleware, but I really like the way that the middleware pipeline works for the request and response processing. And that is that when a request comes in, the order that you set up your middleware to handle that That's the order that you add those middleware pieces is the order that it's going to process the requests that come into your API. So if you have a global exception handler in Unity, you would set like the global exception handler class into the global exception handler, and you would have like a global exception logger, and you would set those very specifically. A lot of it was event driven, so you could set up delegating handlers and you could specify when that was going to run. But in the middleware pipeline, it is easy enough to say it processes them in exactly this order. If you want things to happen before the controller gets hit, you just have to add those middleware pieces before you add the controllers into your pipeline. So you could set up a global exception handler, make that your first middleware that you add, and then you have a try-catch around calling the next delegate in the pipeline, and if there's any exceptions, then it'll get picked up in that global exception handler's catch block. So it makes it a lot easier and a lot more intuitive to know where your exceptions are going and what's happening with your request as it marches through your pipeline. One of the other nice things about it is that when the request comes in, so here we have an HTTP request coming in, you could say that your first one is your global exception handler or middleware. The second piece you could have as logging middleware or some sort of decision middleware that says, do I want to handle this request? Or is there something in this request that makes it where I want to return a 401? Like say they're not authorized, right? That is simply a middleware component that checks their authorization. So you have a middleware component to check authentication, you have another middleware component to check authorization, and those will use the logic in them to decide whether to let it get all the way to the controller or not. Typically the controller is going to be the terminating middleware in the pipeline, and once it gets to that and a response is sent, then it's going to go back to each one of those middleware components and process the code that comes after the delegate was called. Any questions so far? Let's take a look at what this looks like. So right here, we have set up, I bet you guys can't see that, can you? Let me bigify this.
I'm struggling to see it from here.
I can see it really easy from here.
Oh,
So.
I'm sorry.
So here we have set up to use authorization, and that is what's going to add the piece into the middleware to authorize the request. Now this use logging middleware is one I added to log every request that comes in. And then I have another one that I call terminating middleware. It's going to use some logic to decide whether to let this continue on to the controller or not. And so if I go to my terminating middleware, and we use this as an example to look more deeply at middleware, then there's a method that you have to, it's the contract is invoke, and that's going to be the piece that gets invoked to invoke your middleware. And then here, where is it? I look at the header and I see, does the header contain this specific header key? And this is just for an example. If it contains that header key, then instead of letting it go on to the controller, I'm going to set a response of terminate before the controller is called. And I'm going to just send that back to the client so that they know that it didn't go on to the controller. And what's missing in this first piece is I never call the next step in the pipeline. Only if it doesn't have that terminate pipeline set, then it will come down here, it'll log something saying that, hey, I'm not terminating, and it'll invoke the next step in the pipeline. If I don't invoke the next step, then this is where the pipeline terminates. And then it goes back through from whatever spot the middleware is at, it'll still go through the response half of each of the middleware that came before it, but it won't hit any of them that came after it. I was worried that I didn't have enough material to fill an hour, and turns out I definitely had enough material to fill an hour. So I was told that it would go a lot faster than I think, and they were absolutely right. So that's how middleware works. Now, one of the things that I think is really neat about the way that middleware is handled in .NET is you don't have to process everything in the middleware pipeline. You can short circuit the middleware pipeline. And that's by giving it, like this is a minimal API, so I don't need a controller to create an endpoint. I can just say, hey, this is a GET request. Man, that pop-up is really irritating me. And it's going to be a weekday short circuit, and then I have another one for weekdays that isn't short circuited. So at the end of setting up this endpoint, I just give it the command of short circuit. And it'll process that endpoint, but it won't call any of the middleware that it normally would call for processing the request. I know that it doesn't need to go to a controller. I know I don't need global exception handling or the logging or anything like that. So why take up the processing cycles to go through that whole middleware stack when I could just process it in this one handler and return the response? And I don't have to do anything special in this handler except for return my response. I can say context.response.write async and give it the values that I want to write, and now that's what's going to be in the response. And if I've said to short circuit it, it's going to just return that back to the client, and it's done. It's not going to go through any middleware, and it's not going to go to the controller or the endpoint mapper or anything like that. Now let me show you something here that I think is really neat about this. I have one controller. It's a superhero controller that I can use to get and manage all of my superheroes. So in here, I can get my weekdays, and I get back a 200, I get my list of weekdays, and if I come over to my logger, I can see that it went through the terminating middleware. I can see that it went all the way through the system, and then it still returned the weekdays. Now, if I call the one, the endpoint that I have set up to be short-circuited, and I send that, I will still get my 200, I think. Yeah, and I get my days. However, if I look at the logger, I can see that the only thing that got executed was this one handler and none of the rest of the middleware. Now, if I make a call to an endpoint that doesn't exist, like this application started out being like, the weather forecast application, but then I pulled that controller out, and so I still have this request here to weather forecast, and I send that, then I'm going to get a 404. But if I short circuit it, and like I also have a short circuit in my terminate middleware that says don't let this go past my terminating middleware, which is the way that the short circuit works. Even though this controller, this endpoint doesn't exist, I'm going to get back a 200 and the message that my terminating class said to return to the client. So it's not going to break because the controller wasn't implemented. I can return back something, and I can look and see, use some logic or something to decide whether or not to call the controller, and send something back to the caller to say this has been deprecated, or use this other functionality instead, or something like that. Any questions on that? Okay. The other piece that I wanted to make sure that we covered, and so I'm trying to hurry and get to it, is it's a big change in the way that .NET works, and that is whether to use controller or controller base as the class that you derive from. If you're creating an API and you don't have a view that's attached to it, then you want to derive your controller from controller base, because it doesn't have any of the extra functionality for handling views. You don't need that functionality, so why have all that functionality, right? Now, if you do have views, just derive from controller, and controller derives from controller base, but it adds into it all of the processing for handling views. Then you can see here at the top, I have API controllers and attribute on my controller class, but it's not required. The API controller brings some extra help for you, like it does like request validation, model validation, and if the model validation fails, like you pass in something and it can't be hooked up to the parameters that you have defined, instead of just returning either an error or something like that, it'll return the problem details that we were talking about earlier with the problems in the validation. That's what the API controller does for you. It also helps you with mapping your like from body, from query, from service, because you can create in your dependency injection container, you can put a class in there, and then you want a parameter that comes into your endpoints. Maybe you want that to populate that object that's in your dependency injection container. And if you give it the right attribute for that parameter, then it'll populate that class from your DI container. And I think that's really cool. Let me see if I covered all of the best points. Okay, so that's the controller changes. Some of the things that are in controller base is, you used to in the old web API is you could return a string, you could return some object, and that's what would go back to the caller. There's some methods that were set up in controller base for particular well-known status codes. So you have OK, bad request, not found, and then you can set objects to be returned as part of that object that's getting returned to your caller. And so instead of returning like an HTTP response message, you can return an iAction result, and you can return you make a call to OK with or without some data that you want to return to the client, and it'll make that call in the controller base to set that up and return to the caller. HTTP context in the controllers and in pre.NET Core world, a lot of times you would access your requests and your response through HTTP context.current, and that has been completely done away with in .NET Core. And now you have a static class for every request, and that static class is HTTP context, and you can access it from any controller. You don't have to dependency inject it or inject it into the controller constructor or anything like that. It's just available from within the controllers. Now, if you need HTTP context and somewhere that it's not just made available like in the controllers, you can just set up in your constructor, you can set up for it to pass in an IHTTP context, and it'll pass that context into your middleware, some service class that you need access to the HTTP context. Now, something that is interesting, and I think a lot of things here are interesting, I just realized I say that a lot, is that the body of the request and the body of the response used to be plain text. You could open that in your debugger, you could see exactly what text is in there, you could see exactly what text you're sending back to your caller, but that has been changed from being like a string field to being a stream field. So you can't just get in there and see what the text is. Now the neat part about, or the kind of the gotcha with this, is that it's one way, forward only. Once you read that stream is gone. So if you read that stream, the request body stream in your middleware, before it gets to the controller won't have access to that stream because you've already read it. Right? So it's like, okay, well now, how can I log the request in my logging middleware and still let my controller get it to be able to process it and do what I actually want it to do? The answer to that is that you need two pieces set up. One is in your program.cs where you're configuring your application, you set up the app.use and you take in the context and the next. So this is a piece of middleware. And in that middleware we're saying, hey, the context request, I want to enable buffering. And the enable buffering allows you to, once you've read the request body, you can set the position of that stream back to 0. But if you don't set up enable buffering, you can't rewind that stream back to the beginning. You might say, oh, this is awesome, we'll just add enable buffering to everything. But there is a performance cost to enable buffering, because now instead of the stream being just a stream that's streamed to one spot, in the code for enable buffering, it's going to actually take that and either copy the data in memory, or if it's over, I think it's like 30K or so, then it's going to create a temp file, it's going to copy that into the temp file, and then whenever you rewind the stream, it's going to read that and put it back into a stream for you to be able to read again. So if it's not something that you're going to do, then you don't want to enable buffering and take that overhead for every single request. Now you might say, okay, this is in the middleware, but why wouldn't I just set it once and we're good to go? And that's because your controller, your middleware classes, they are spun up unique for every single request. It creates a new HTTP context, it creates a new controller. So you can't really store in your controller a private field of information that you want to be available every time this is called. You need to have another way to store that. You can use a static, of course, set up a repository. You have options. Just realize that that controller is torn down and recreated for every single request. And if you want to reread the body, that's how you do it. Now, rereading the response body is a little more complicated. And this is the last thing I have. So, if you want to reread the response body, then you have to start out by taking the original stream and you have to save it off somewhere. And you replace that original stream with a new memory stream. And that new memory stream is what your controller is going to actually write into. And then whenever it comes back from your next, so the next is the delegating call, the delegate to the next step in the middleware, which will get passed all the way down to the controller and then all the way back up through the response pipeline. And then after that, now you have a memory stream that's in your response body. And just like in the request body, you can rewind that because now it's a memory stream. And a memory stream is the same way that that enable buffering in the request body makes it available. I can read the response body. For some reason, this thing is just not letting me scroll. But I can log that, and then I can set the memory stream position back to 0. Use the good old scroller. And then I copy the original body into, or copy the memory stream, this was coming back from the controller, copy that memory stream's content into the original body stream, and then I set the original body stream as the body going back to the caller. Does that make sense? So, if you don't take away anything else from this, it's if you want to read the response body, it's a little complicated, but this process will get it done. And again, there's some cost to this, right? So decide, how much do I need this? And do I need it on every request or only on some requests? Because if you don't need it on every request, then you can save that on some of them. And that's what I wanted to get through today. Any questions?
So why would you want to, why do you think they turned it into a stream instead of just a bunch of text?
Yeah, so as a bunch of text, it's a little more difficult to stream that like large chunks of data back to the caller, right? It's a chunk of text, and it's going to have to go through the normal like networking packets to be sent back. As a stream, it sends back the beginning of the stream, and then it continues to send that data in kind of chunks back to the caller. So you get better performance. Your first byte back to the caller comes a lot quicker, and then it just continues to send additional data through the stream.
It sounds a lot like a content stream class sort of usage, right?
Yep, yep.
They're just doing it by default.
That's right, yep. It's just built into the system so that you don't have to do anything special to be able to take advantage of this. It just makes it where the whole system works more efficiently.
So if you're returning back a file for like a download or something, you're just naturally going to get a stream
Yep,
to work with, and then it's you don't have to do anything special.
that's right. Yep, Yeah.
So stream is immutable and stream is not, so.
yeah.
And you can add that on the fly while streaming, you have to populate it before sending.
Microsoft has been making a march over the years. There's a guy that I work with that is a big fan of F#, and one of his favorite parts about it is the immutability of everything in F#. And Microsoft has been taking C# in small steps and moving it closer and closer to that F# functional programming concept of immutability. And so this is just part of that they make it by default that it's immutable. If you really want to get in and do stuff with it, you can, but by default, you can't. Yeah. Any other questions? Okay. Well, thank you very much for your time. I really enjoyed getting to speak with you guys.
Thank you.
We've got some good
And
ones.
now it's time for the free stuff.
Yeah.
Thank you.